Welcome back, my students, to chapter 6, biochemistry. Okay, in the first class we talked about the monosaccharides. Here we have to complete the types of saccharides. The second type, we call them oligosaccharides. Oligo, it means few or limited. They contain from 2 to 10 units of monosaccharides. Only we'll talk about the disaccharides. So from the oligosaccharides, we will talk about the disaccharides only. That means if you have 2 units of monosaccharides. The general formula of disaccharides is C12H22O11. Why we write it like this one? Because if we have 2 disaccharides, maybe C6H12O6, and this is another one, another formula, we have 2 units. Remove H2O, the process we call it condensation here, removing water from the 2 compounds and give us only 1 compound. This one we call it condensation. So C6 and this is C6. How many carbon? Yes, we have 12. Hydrogen we have 12 and 12. Yes, we have 24. 24 minus 2. Yes, it is 22. And oxygen we have 6 and 6. How many? Yes, they are 12. Minus 1, so we will get 11. So this one is the general formula of disaccharides. They are formed by the condensation of 2 units of monosaccharides. Yes, what are they? Yes, they are disaccharides by removing water. But this one, look, the disaccharides, they have the same formula. Yes, C6, is it glucose or fructose or galactose? We will see here. If we have, look, all of them contain, yes, glucose. If we have glucose and fructose, so we call it, yes, we will get the disaccharides. What the disaccharides here? Yes, it is the sucrose. We call it cane sugar. If we have 2 units of glucose, so we will get maltose. So we call it barley sugar. If we have glucose and galactose, yes, we have here, we get lactose, or what we call it, the milk sugar. So sucrose and maltose and lactose, they are disaccharides. They contain from 2 units of monosaccharides. Look, how can you memorize it? This is GFS or GGM or GGLA. Yes. Now this one is sucrose, maltose and lactose. You have to know the other names and the monosaccharide that includes in their structure. And you have to notice here, all of them contain what? Yes, contain glucose. Start with glucose. If you have glucose, fructose, sucrose. Glucose, yes, maltose. Glucose, galactose, yes, lactose. By the way, this is the name lactose. It is a part of the galactose. From here, lactose. Okay, this is the structure formula for all of them. What do you notice here? Yes. How can you distinguish glucose from fructose from galactose? Look here, the first one. This is the monosaccharides. The first one, yes, this is glucose. The same structure. Remove H2O. So OH with H are removed, and this is removed as H2O. From here we have, this is H and this is OH are removed, and the remaining is only 1 oxygen. This is the 1 oxygen, joins the 2 molecules. So this one you call it maltose. Glucose plus glucose removing H2O. removing it is from here, okay, and you're from carbon number 4 and carbon number 1, okay, so you will get here free functional group. So this one, it is removing H2O, so this is maltose. Okay, what about this one and this one? Yes, this is 5 member rings and this is glucose. So this is fructose, 5, it is fructose. And this one, yes, it is glucose. Remove H2O. Okay, H2O is removed here from carbon number 2 from the fructose, and carbon number 1 from the glucose. Remove H2O, so you will get the sucrose. Okay, what about these two? What are the differences? Yes, 6 member ring, 6 member ring. As I told you before, if we have OH only up, so this is glucose. Okay, this is carbon number 3, 1, 2, 3. But here, this is galactose. How you know it is galactose? Because this one, look, 1, 2, 3, and 4. Carbon 3 and carbon 4, the OH both up. That means they are left side. But here only OH up, so that means number 3 only left side in the open chain structure. So you have to remove H2O, yes, and you will get what? The bond between them, this is the oxygen, joined the two molecules. So, you know, we don't memorize the structure, just we have to know the names. Glucose, glucose, maltose. Glucose, fructose, sucrose. Galactose or glucose, galactose give us what? The lactose. So these are monosaccharides and these are disaccharides. We will start with the first one. What you call it? Yes, it is sucrose. It has another name. What is the name? Yes, it is cane or beet sugar. It contains glucose and fructose. So sucrose is known as a table sugar because it is this sugar that we use it every day. Sucrose is found in sugar cane and in sugar beets. Sucrose is non-reducing sugar. Okay, again, this one is non-reducing sugar. This is very important point. So the only disaccharide that is non-reducing sugar, it is sucrose. It doesn't form red precipitate with Fehling or Benedict solution. Why? We will see that later. So it doesn't react with Benedict's or Fehling's reagent or solution. Why? Because they have no free functional group. What does it mean? Also, I will explain it later. So, the reason here, no free functional group. It is hydrolyzed to glucose and fructose. It is the opposite of the formation. Hydrolysis is the opposite of the formation. So, they are formed from glucose and fructose, and they are this one, it is hydrolyzed to glucose and fructose by enzyme in the body or in acidic medium. Okay, so this one is the cane sugar, or this is the last product when it is manufacturing. Okay, this one is the beet sugar, and this is the last product. Again here, I want to explain why they are, it is non-reducing sugar. So this is glucose and this is fructose. This is carbon number 1, this is the functional group, and this is the functional group at carbon number 2. Okay, you have to remove H with OH as removed as H2O. So, and you have to join the rest. Here we have the only one oxygen you have to join. The functional group in glucose, it is carbon number 1. And the functional group in the fructose, it's carbon number 2. Now, carbon number 1 is the functional group number 1, and the functional group number 2, they are joined with the bond. So there is no free functional group to react with another substances. So the sucrose, non-reducing sugar. Why? Because there is no free functional group. There is no free functional group. Free functional group means carbon number 1 and number 2 are joined. So there is no one is free to react. That's why it doesn't oxidize. Okay, and it doesn't reduce, the Fehling or Benedict solution. Okay, but what about the maltose and the lactose? We will see they are reducing sugar like the monosaccharides. Why? Because they have free functional group. But again, sucrose is the only, sugar or disaccharide that is what? Non-reducing sugar. Very important point. It is non-reducing sugar because it doesn't have a free functional group to react. The second one, we call it the maltose. It comes from the malt, it means the barley in English, or this one we call it the maltose. It contains glucose and another glucose. Here we have, it has a free functional group. So maltose is a reducing sugar. It is hydrolyzed to 2 units of what? Of glucose. It is the opposite of the formation. Yes, we will see here, yes, look. This one is glucose and this is another glucose. We join them, but the join between what? Between carbon 1 and carbon 4. This carbon 4 from another molecule, it is not the, the functional group. So one functional group from one glucose reacts with carbon number 4, okay, for the another molecule. But here we have carbon number 1, look, it is what? It is free. It is this one, carbon number 1 free in one molecule. So this one is free. If it's free, so it can react. That's why maltose is a reducing sugar, because it has free functional group. Okay. The third one, we call it the lactose or milk sugar. It contains glucose and galactose. It presents in the human milk, the mother milks, from the percentage from 5 to 8%. But in the cow's milk, it is 5%. So large amount in what? In the human being, milk. It is the mother milk. It is sweeter than what? Than the cow's what? The cow's milk. Because it contains large amount of lactose. It has a free functional group also. So lactose is a reducing sugar. Okay. It is the only sugar that can not be what? Fermented. Yes. So all sugar, can be changed to what? To alcohol, except what? Except lactose. Why? Because it is what? It is the best food for the babies. So inside the human beings, if it can be fermented, they change to the alcohol. So the babies, maybe they drink what? Alcohols. But Allah subhanahu wa ta'ala, prevent its fermentation. It hydrolyzed to what? To glucose and galactose by enzymes inside the body or outside by in the acidic medium. So again, here we have the only sugar that can't be fermented is, yes, it's lactose, it's milk sugar. Okay, the sugar that's present in high amount in the human beings, what you call it? Yes, it is the lactose. Is it reducing sugar? Yes, because it has a free functional group. So here again, look, this one like the maltose, it has free functional group. Okay, so this one we call it, reducing sugar. Yes, what are the properties of disaccharides in general? Okay, in general, they are hydrolyzed into in the presence of the mineral acids or enzymes, forming 2 units of monosaccharides. Yes, sucrose, hydrolysis of the sucrose give us what? Yes, the 2 units that is, the sucrose are formed from. Yes, here we have the maltose. Yes, hydrolyzed to what? To glucose and glucose. Yes, lactose. Yes, hydrolysis of the lactose give us glucose and galactose. It is the opposite of the formation. Hydrolysis, opposite of the formation. As we know, maltose and lactose are reducing sugar like what? Yes, like monosaccharides. Because they have a free functional group. They reduce Fehling's solution or Benedict's solution and forming brick red precipitate. Sucrose is the only disaccharide. This is non-reducing sugar because no free functional group. Sucrose is the normal sugar used daily, in what? In tea, coffee, and sweets. Yes, up to here, we have to stop, and thank you for listening.